All right, before we get started with our today's class, anyone, any queries based on the previous session? We will first discuss that off, and after that we will get on. So possibly first 5-10 minutes, quick resolutions. If at all there are any, we will look into them, and then I'll get on to our today's session. So continuous practice is expected from each one of you, and possibly once we get on to our data related activity, I would give you some assignment also so that you can work on it. Possibly that would create some interest in the class as well, some kind of activity that you do parallelly to what I discuss in the class as well. Okay. Okay, print formatting we will keep on using, but yeah. So you look at, I'll again take you through. So this was the print formatting. So basically, one way, there are multiple ways. Okay, the second function is not working. Okay, possibly you can post these kind of queries in the group, because some of these issues can be resolved among yourselves also sometimes. So my suggestion is, let's use the group effectively for solving the queries, right? Anything that, I mean, most of the things, I think at least the initials, we have a lot of people who are really good at Python also in this group. So they can also address some of your queries immediately. So let's be active, at least among yourselves. There can be a lot of activity, and possibly if something is not resolved, we can discuss those things in the class. Or even I would also see, I generally see WhatsApp only once or twice in a day. But yeah, whenever I look at it, I will try to respond in case there are no responses from your friends. I think that's the best way, right? Merit certificate, I think there are some administration difficulties, Shubham. So right now it is not a merit certificate because the evaluations and all have to be very much top class, because if we are talking of a certificate from IAI, there has to be a lot of proper evaluation mechanisms and all. Right now we have not given the enough thought to that. I don't think the institute has given that much of thought. So this ends up as a participation certificate. But yes, I mean, at the end of the day, your knowledge is what counts. So we'll do some assignments and all so that you get that real hands-on kind of a work experience. Yeah. How did you open the help box while exploring different functions? Okay. So you just put your cursor here. You just move your cursor onto the function, Divya. Any function that you write, print function, there is a built-in function called print. Or possibly we have used some other functions yesterday, upper. I put my cursor here. So this is the method called upper that is coming out, right? Or possibly if I want a new function, or if I want a function to be written, put a dot. So the help is simply, you just, you just put, please share this Google Drive. Did I not, are you not able to see the screen? I have already shared this file, Ankit. It was shared in the groups. Sorry, in the WhatsApp group also, I remember sharing it the other day, immediately after the class. So there is nothing that I have done new, or even if I do something new, I will share it after the class. All right. So let us move forward. Okay, so yesterday we started off even with the numericals. So we said data types and data structures. This is what we were discussing. These are sometimes important. I mean, on a periphery, they might look like not much of interesting information, but typically data types are associated with single variables. Like most common things are string and possibly integer, date. These are the various, or boolean. These are the various data types associated with each individual value. And we also talk about data structures. Structures are generally about collection. Collection of data. Again, there are different kinds of structures. Okay, I will answer your question, Nikita. Just give me a minute. So data structures are associated with collection. Now, what is this collection saying? We will go ahead with this collection. So the collection means collection of let's say integers, collection of strings, collection of boolean values, etc. So it's a collection. So just like we say, man is a collection of probably Vamsidhar, Ankit, and so many such kind of names, right? So a group. Now again, there are slight differences. I mean that could sometimes you may argue it as an object versus a class, but I'm just saying a group of people, right? So this group I can very well refer, or possibly I'll not call it as man. I'll call it as data science training group, right? And these are all the members of this group. So what is that we say? This collection can be addressed in various ways. So we have one such way of addressing that collection called as a list. We have something called a tuple. We have something called a dictionary. We have something called a set. And we also talk about variables. So these are all list of observations. So possibly it's as good as saying numbers 1, 2, 3, right? If I put them like this, it is a list. If I put them like this, it is a tuple. If I put them like this, it is a set. Right? Each one has a different benefit. If I put them like this, key value pair. Right? This is called dictionary. What is the difference between the four? I'll explain. I'm saying these are the different notation. Now, in some cases, additions and deletions are possible. So in this case, so when we get into each one, we will try to see, right? Possibly if I am representing in the form of a list, there are so many benefits. Additions and deletions are very easy to perform. Whereas if I'm taking it as a tuple, additions and deletions are not allowed. So in some cases, I don't want to add something. I don't want any kind of insertions, any kind of deletions, etc. Then I may want to represent something as a tuple. Or here, what happens is the duplicates are also possible. So I can add one more one to this list. Whereas if something is in a set notation, even if I add one more one, the set will still be 1, 2, 3. A duplication cannot be possible. So we will see that each of these, what you have to understand is in any programming structure, the data structures are the collections, how groups of data can very well be represented. Right? That is the broad intention here. All right. So now quickly let's look at, so if you are looking at individuals, integer, float is your decimal, Boolean, complex, strings, etc. are there. Now, as I said, we can very well look at the data structures. So collections, list. So this is the most general version of a sequence. So when you are talking about groups, the most common thing in Python is a list, because we can talk about additions, deletions, insertions, lot of things. Now that means we are bringing in a lot of flexibility. So they are mutable. So this is the word. Mutable means elements can very well be changed. So whenever we want our list to be dynamically changing, then it is better, whenever we want our data collection to be dynamically changing, then it is better that I create it as a list. So if we quickly look at some of the simple coding part, I've simply said my list is 1, 2, 3, and I have put it in a square bracket. Or my list, the another advantage here is I can put different data types. Data types are individual values. I can put different data types in each list. Or they can be homogeneous, or they can be heterogeneous. Data types can be different. Now, when I use this len, okay, so possibly you keep your cursor there, it will give you the help. Return the number of items in a container. So in case if I put this len for a string, it will give me the number of characters of the string. But if I put this len for a list, it will tell me how many elements are there in the list. So there are 5 elements in this list. Okay, so all these are important. As I told you, we are right now learning the building blocks without knowing the build. And I'm sure some of you are already well versed with Python. You might have attended some other training programs on Python, but I suggest you please bear with me because I want everyone to come up to the mark, right? And it's not that you will lose out on the other aspects. At the end of the day, learning is important for each and everyone. And because it's a heterogeneous group, I will have to spend some time, because in the curriculum also we have mentioned that the basic Python would be covered. Okay. Okay, now I think people are answering. You look at the answers directly in the chat box. You try it out. In case something is not coming, then possibly I'll intervene. That is the way we can utilize our timing better. So you yourself try to answer the queries of the people who have posted, so that it would be a learning for you also. Okay, so now I am telling, now I can, as we said, lot of insertions, deletions, and lot of such kind of things are possible for a list. So let's assume that my list is containing 3 strings and 2 integers. So this is strings, this is a length of 5. I want to append, okay, or I may have another this thing 1, which is a numeric, which is an integer, float. Now I have one more list within a list. This is called a nested list. I can have a list within a list. So my first element is 1. Second, sorry, 0th element is 1. First element is 2.3. Third element is this entire list with the values A and B. And third element is New York, which is a string. So to this, let's say I want to append one more value. Append is always adding to the last. And I am adding individual value, single value. Then I am doing a kind of append. But if I am adding another list to the existing list, then I am doing it as an extend. So in many cases, possibly I might have one list of boys, I might have one list of girls, then possibly I do an append of one list to, sorry, the extend of one list to the other to create a list of employees, right? So that is one. So which means I can think of adding new elements to the list. Then the most important part is slicing, accessing subsets of values of the list, right? So I think the same thing goes with the question that someone has raised, Nikita has raised. You look at it here. Start. So whenever you want a subset of anything, right? So in a string also, if I want to write in a reverse order, I'm talking about taking a subset and then putting it in a reverse. So the normal structure is always like this. Start to stop, start to end with a step. So here also, before the first is to first colon, it is about the start. The second colon, it is about the stop. So possibly you give some numbers and start working it out. Right now, there are no numbers, but you give some numbers. Possibly I'll show something for you. I'll go back. So just for explaining, because at the end of the day, the explanation is important. So I'll call something S equal to Vamsidhar. Okay. Then I'll put S. Then we'll say 0 colon 4 colon minus 1. So instead of putting colon colon minus 1, I'm saying 0 colon 4 colon minus 1. Or sorry, I'll put it the other way. So here what is happening, I am starting with the fourth element, right? Fourth element is 0, 1, 2, 3, 4. So I'm starting out with the fourth element I. I am ending up with the 0th element. Ending up with the 0th element is V, but not included. And I am moving in a -1 kind of a direction. -1 means from I will come to S, S I will come to M, M I will come to A. So what is printed is ISMA. So what is happening? Whatever the number I put here, that is the starting. So if I don't put any number here, then it means that it is the last value. If I don't put anything, if I put something here, that is the starting. If I don't put any number, then it is the ending. It is all, which means it is taking the length, which is the last. Similarly here, if I put 0, it is talking about the starting. If I don't put anything, it is coming to the ending here. Right? The ending on the other side, which is like a starting. And we are talking, if I am putting -1, so which means it is taking all, starting. So we are not putting anything in start, we are not putting anything in the end. So it will take the whole text. And that whole text, we are saying, work it out in the -1. So come from the reverse. Reduce 1, 1, 1 and start printing. So that is how it gives me the reverse. Now you should actually plan out, right? What if I give 6? Right? What if I give -2? How is this coming out? Just explore. So from 6, I'm coming back here with a -2. So every second element will come. H, I, M, V. Right? Every sense. Now, in case I give a +2, HR, because now it's in the positive direction. So I'll start with 6 and the whole text will be, is to is the whole text. So if I'm just putting this, it means take the whole text. But if I'm putting this extra, then by what steps, in what steps? So it's as good as if I put this 1, then it is the entire Vamsidhar will be printed. Then if I put 2, then it is VMIHR, every alternate. So what is that we are saying here? Starting point, the ending point, and the increment or the decrement. So the same thing you can do in a list also. Now this is what we are doing in list. Starting, ending, and step. Right? So now you can practice. Yeah. I'll come to them. I think we'll go step by step. I don't know if there is anything. So append is for appending individual values. Extend is for appending a complete list to another list. So you are extending a list with you are appending a value to a list. You are extending a list to another list. I don't know what. Please clear, sir. I don't know if any question is unattempted. Which page are you pretending? So this is the same page. Can a particular structure be converted into another? Yes, yes. Tuple can be converted into a list and vice versa also. Okay. We will talk about them. And you can experiment also. Just Google out whatever comes to your mind. Right? You will get functions. Okay, only where function is available that can be converted. If the function is, I'll come to the conversion part. All right. So now, so this is the list. So either you can give it as a 3-part thing, start to end to step, or it could be a 2-part thing, in which case the increment will be either +1 or -1, depending on whether start is greater than the end or start is lesser than the end. Okay. So here you could see you have created a list. Now, one more thing. Range is one more function that we are talking of. Range is, it starts from 0. if you don't define anything. So range of 10, it means it's a number 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That is called range of 10. So it is creating a list containing 10 numbers starting from 0. And that we are making it as a list. So what will happen? So the moment I said list of range of 10. Range of 10 is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, because it's a list, it would be shown like this with a commas between. Now, when you say print list, it will print all of them like this. Print elements from the index 4 to 7. 0, 1, 2, 3, 4. So 4 to 7. So what should be printed? Seventh one should not be printed. Fourth one should be printed. So it is 4, 5, 6. Alternate elements starting at index 0. 0 to, I did not put anything, which means till the end, with an increment of 2. So 0th element, 2nd element, 4th element, 6th element, 8th element will be printed. Just keenly observe it. And if I want every third element starting at index 1, so then I say this is the first, start at this point, end there is no end, and you increment it by 3. So which means 1, 4, 7 will be printed. So just observe this. This is one important. This is a kind of a subsetting, slicing, subsetting. One of the most important functions that you would be using as we move forward. Now, right now we are just learning the building blocks. But once we get into a data, we will see we may have to apply all these things on different blocks, right? On different data elements. So there the pace of the movie goes much faster. So more and more practice at this level will give you a very good hold if we have to work at a later point. Now, as we have already seen, append is adding the elements to the end of the list. Extend is extend one list with another list. Then we can also say insert. Insert, you can very well specify the location where you want to put. Now, let's say we had this list, right? L. L was the name of our list. L dot insert. So you see, if you type 1 or 2 letters, you will get a kind of a drop down, right? You will get the function. Now you can very well say what is this insert? You can very well specify, you can very well insert in whatever location. You could see here, you could insert a number 4.5. Now why is L not defined? Okay, I did not run it, looks like. So if you really, okay. Yeah, I have to specify the location. Okay, so we will print L now. You see here in the location number 3, a number called 8 was inserted. So this is the location location number 3, 0, 1, 2, 3. In the location number 3, a number 8. So if I want to insert somewhere in between, then I can use this insert scenario. Is there any environment which can show which variables have been created? You can simply print it, right? You can simply print it, and you can look at the list of all the variables, right? I got the point. I think there is an ls or something. I'll just check that. Okay. Then we are moving to the next. Of course, we will see a lot of functions for each. Now, if you really want to know what all you can do with this, you see here, L dot. You can insert, you can append, you can clear, you can copy, right? You can count, you can extend, you can index, you can remove. So there are, you go through each one of them. Yeah, so actually, you're right. So you can click on this. These are the various variables that you can look at. Yeah, this is one more way of looking at. You have a command also that lists out all the variables. The other way is you look at clicking on this. You can get the list of all the variables that you have created. Okay, so this L dot is giving you what are all the functionalities that you can perform. Then we move on to the dictionaries. So dictionary, as we said, it's a key value pair. Now you look at it here. I create it like this. Key 1 colon value 1. Key 2 colon value 2. So this is more for customization. Let's say I create marks 1C colon 50. Someone else colon 40. So I give I create dictionary where, I mean, this is as good as a table, but we are not maintaining it in the form of a table. We are maintaining it in the form of a key value pair, because sometimes I may not want to interact with any other external database or anything. I want to maintain everything in my environment itself. So in that case, key value pairs. Now there are so many applications that we would be seeing as we move along, especially in the data science. The various parameter values to different models are typically treated as key value pairs. Different models that you create, the parameter values for the different models are passed as a dictionary, because many a times what happens is you may give the input values in different order. You may not give the input values in the same order. You may want to give them in a slightly different order, or you may want to omit one value and let the system take the default value for that. In those kind of cases, if the sequence cannot be maintained, the problem could come up. But rather than maintaining it as a list, if I take it as a key value pair, I can just give the key name and enter a particular value. It would be associated only with that particular parameter. Now that is where the key value representation, which is otherwise called as a dictionary, is important. Now here, rather than accessing 0th location, 2nd location in list, we are accessing like that, right? 0th location, 3rd location, something like that. Here I am not accessing like that. Here I am accessing it in the form of a key. So my key 2, the value is value 2. Right? So this is one. Is it possible to hold a variable permanently as it is removed automatically when we restart PC or collab? So what do you mean by variable holding permanently? This is a Python environment. So either you store those values back to a CSV file or something, a text file or a CSV file, which would be saved as a file in your system. I will talk about that. Right? That is what we are saying as permanent storage. Only it has to get into the file system so that there is a permanent storage. So whatever the values that you are, this is a working environment. So if you want something as a file system, right, it should be created as a file, then it is a permanent storage. So you either export all these variables. I'll show you slightly down. So we'll have to export all these variables to a file system, either a text file or something like this, right? We can call values from key. How to call key from a value? Yeah. So we will. There is something called indexing, right? So the indexing can help you to get the key value from the value. So you can explore about the indexing. Okay. So now here the another advantage is in dictionary also you can very well change the values. So for a particular key, I want to override. Earlier this value was value 1. Now I am overwriting it with 1, 2, 3. So now if I print it, I'm going to get key 1 is 1, 2, 3, key 2 is value 2. Then here I can also say, now you see, I'm subtracting. Now key 1 is 123. So I can take my key 1 and I subtract 120, which means I can do numerical option, numerical, what is that? I can do numerical calculations, anything, because once I get my dict of key 1, then it is nothing but 123. 123 minus 123 is going to be a 0. So that I assign it to key 1. So I can do this kind of assignments also. So I can play anything with the key value pairs, right? So this is one more way. Additions and subtractions. This is a Python way of, possibly you can do it like this. I said here my dict key 1 minus 123 and I assign it back to my dict key 1. Right? Now, in these kind of cases, this is a shortcut way of representing the same. My dict k1 minus equal to 123. So it means my dict k1 equal to my dict k1 minus 123. So the same thing you can very well put it for plus, minus, multiplication, division, all of them you can very well put this. Existing value minus or plus or something, and again reassign it to the same value. So this is what is a built-in method for doing a self-addition, self-subtraction, self-multiplication, and self-division. Then you can very well create dictionaries, right? You can very well create, we talked about creating new value pairs, etc. Then the next thing that we are talking about is set. Set, as we have talked slightly earlier, they are represented in curly brackets. So you can first define something as a set in any of them. You first define it as a set, then you keep adding the values to the set. Okay, so possibly I'll show something. You x dot add 1, x dot add 2, x dot add, but again I'm putting 1. And then we are printing x. It will show only 1 and 2. Though we have added 1 once again, in set that does not happen. Possibly y equal to list Sorry, why is not add append? Because y is a list. You see here, that is the difference between the list and a set. In a set, in both the cases, we have added the same thing, right? But we are seeing that, I cannot add duplicates in case of a set, but I can very well have a duplicate in case of the list because the objectives are different. In the list, we have a different objective. Anything that comes. So if I have to store duplicate values of a data, then I should not store it as a set. I should store it as a list, right? So there are multiple uses. As you keep thinking through, you will get different use cases, right? So that is what we tried here. I think I have tried it here. So for the list, now someone was asking, can I convert one data structure to the other? So look at it here. L is a list for me where there are so many duplicates. So this is possibly the list of values that I get when I throw a dice, right? So I'm noting down all of them. But suddenly I want to know what are the various unique values. Of course, there are various ways of doing that. But suddenly you convert it into a set, you will get only the unique occurrences. So you simply say set of this, and you are going to get this, right? And similarly, you can talk about from a set. From a set, definitely, if you convert it into a list, it's just that the same values will be there. Duplicates will not come because it does not know what duplicates are there. So yeah, possibly you can explore. I have shared a book also. So possibly something more if you want, you can explore it in that book or any quick tutorials that you find on Google also, you can keep exploring because here we can't spend too much of a time on the basic constructs. We have to move further. Then, yeah, sets always arrange it in the order also. Let us experiment it out. Sometimes I don't give too much of importance to these things, but yeah, it's always better to clarify it out. Yeah, it is arranging as well. So you can quickly play around and you can get your this thing. Now the next thing that we are talking of is, now we have, what is that we have done? Each individual element, different types. Then groups. What are the different kinds of collections that are there? Now, how do I work with these data types and data structures? How do I create some kind of rules and logic? And that is where we are bringing in the programming constructs. So the typical programming constructs that you see in any programming language is the looping, right? You repeat. Loop is nothing but repeat an action. So you generally see there are many, but for and while are the very common loops that we hear in any programming language. Similarly, we can talk about conditional statements. If. So if then else. So in some construct, every programming language has this if statement, if block in some form or the other. The syntax could be slightly different, But at the end of the day, every programming language has this conditional. Now, comprehension is something more specific here. We will talk about it, right? So, of course, in some other languages also we do have. So, the first thing is if, elif is nothing but else if, and else. So, we have three things here. I'll represent that first of all. So, here, so I'll say x greater than 10. So there might be an yes or a no, right? Or possibly no and a yes. X greater, not greater than 10, we'll say very bad. And if x greater than 10, we want to say good. Or possibly one way is simple, say good. So what is that we are saying? If x greater than 10, good. Otherwise, if we say, rather than writing a bad here, we'll say if x greater than 5, then we'll say average. Else, we say bad. Let's say we want to bring one more dimension. Then the second if that we write it as elif. And the final thing, without any if, we will write it with the else. So that is where is this if, elif, and else block. You see here, if I am, so these are the three things, a equal to 5, b equal to 4, two values we have given. If a is greater than b, so you remember here, if, then there is a condition, then there is a colon. So if a is greater than b, which means if it is true, then here the most important thing is you have to do an indentation. So if you see here, I'll write it. If a greater than b, colon, the moment you put a colon, it identifies that it is a block code. You put an enter, you will not get the cursor to the extreme left, you will get it slightly aside. That is what is the auto indentation that we are talking about, right? Indentation is very, very important in Python programming. If you don't do a proper indentation, then the results can very well get affected also, right? So if a is greater than b, you do an indentation, print a is greater than b. So only this statement will be executed if a is greater than b. Then elif I came out of the indentation. Then now I am saying if b is greater than a, then within this, if so, which means if this result is true, then it will print only this part, right? Else, which means I'm not doing any more verifications, then we say both are equal. So just observe this, and if there are any queries, let me know. This is one more. This I have already shared in the WhatsApp group in the last class only. How to come out of indentation? Just press the backspace. Just press the backspace, you will come out of the indentation. Let's say here you are in the indentation. You either press Shift Tab or you keep pressing the backspace. Shift. So normally Tab also will take you. If there are logically here there is one more extra tab, but because there is nothing inside, even if you put two tabs, but you have to be consistent. But normally one tab is the typical indentation. Are we fine with this if, else, if and else block? You may have to practice. You will use my elif multiple times. You are right, Rema. Okay, it is important. Can we use tab instead of no? So this is very much required. This is telling it's a block, right? This will tell that this is the whole syntax of a if statement. If, then the condition, then colon. So that entire thing is a part of the if statement structure. It is important to keep a good understanding of how indentation works in Python to maintain the structure and order of your code. As we move along, when we are writing our own functions and all, we require the indentation to be much more comfortable, right? You have to practice that part. Then we are talking about the for loop. For loop is repeating a series of steps repeating n number of times. Repeating the same activity n number of times. No, you cannot use two ifs and then else. It does not work. We have that example. Just wait. So we can very well take the second example that our friend is suggesting. So we'll say I don't want to, or if someone has already written it, just write it out there. So I'll so that it will save some time. A percentage A slash slash Okay, that's the reason I did not use this example. In our example only we'll discuss. Okay, it's not A. This is what? Yeah, okay. This is A percentage. So remainder is for, because in different languages we have different syntax. Okay. So let's understand this. A percentage 2 means the remainder when A is divided by 2. Remainder when A is divided by 2. If that is equal to 0, here in R and Python, double equal to, okay, versus single equal to. Single equal to is always about assignment. Double equal to is always for checking. Right? So when I say x equal to 5, then it means that x is given or assigned a value of 5. When I say x equal to 5, x double equal to 5, check whether x is equal to 5 or not. So that is the difference between single equal to and double equal to. Okay. So now go back. So what is that we are saying? If a percentage 2 is equal to 0, then we are saying print even. If a percentage 2 equal to 1, print odd. Else print not categorized. Right? So you can very well do this kind of an exercise and you can extend it also. All right. Now we are coming into the for loop. So for loop is more for an iteration. So you can iterate through the entire list. You can iterate. You can give like start point, start. We have that, right? Sequence, start, end, step. So you can very well go in that manner also. You can loop across many things, right? So you can iterate over strings, you can iterate over lists, you can iterate over tuples, you can iterate over anything for that matter. So simply look at this. We'll see a very important thing here, list one. Let's say I'm taking, these are the values of the list. Now, you look at this. Now you will go step by step. For the construct is like this. For x in something. For x in, let's say, list or tuple or anything here. This colon. So what is that we say? Am I clear? Am I audible? Just can one or two of you can confirm. It looks like I got some message out here. Low system resources may affect your audio. Okay, fair enough. Yeah, I think one response is sufficient, please. Yeah. So this is the way we are representing. So let's say what we are saying, let's say I have a list L 1, 2, 3, 10. So what I say for x in L means take every value of L. So in the first iteration, x will take a value of 1. In the second iteration, x will take a value of 2. In the third, it will take a value of 3. In the fourth, it will take a value of 1. So it's as good as saying for x in L, print x squared. Right? Of course, we will x into x, but I mean x squared and all, we can very well, or possibly x double star x 2. Either I put x into x or x double star 2. Okay. So it will print values like 1, 4, 9, and 100. Iteration is meaning of iteration. So if I want, so okay, the question is print the squares of all numbers from 1 to 100. If this is the question, print the squares of all numbers from 1 to 100. So I will simply say, of course, there are multiple ways possibly, right? I am giving you based on what we have learned. So I'll first initially create some X, which I will call it as a range from 1 to 101. So this means it will print 1, 2, 3, and so on up to 100, correct? So I'll simply say for, I will now take each and every value and compute the square. So for I is just a variable in X. So take each and every value of X and print I squared, which means first initially I will take a value of 1 and it will print 1 into 1, which is 1. Then again it will keep on looping until all the values of X are over. Until all the values of X are over, it will keep printing. Is that clear, Ankit? That is iteration. You are repeating a same activity so many times. So here you could see this question is about print, right? So here we are simply saying these are the list of values. For number in list 1, if so number is a variable. So you are simply taking, yeah, I think you got it. So for each number percentage 2 equal to 0, which means it is even. We have already looked at this part. Print number comma end equal to this. So print the number if this is even. So the end equal, so if it is even, we are printing the number. And this is an extra parameter that we are providing. So if I don't provide this, you look at this difference, right? I'll not provide this. I'll just say print number. So it will print as blocks 1, 2, 4, 6, 8, 10. New line. But if I provide this, it means that that new line will not be coming. We are always printing it on the same line. So these are some of the very minute things. Possibly you don't need to bother much sometimes, right? Because in a data science problems, of course, in some problems, these are all very, very essential. But in data science, we go for huge data sets. So even if I get something in a row or a column, it should not matter much to me as long as I know how do I access all of them separately. Okay, so now this is a very interesting question. So you tell me, now someone can look at it and tell me what is happening in this. So initially I am taking list 1. This list 1 is containing 4, 7, 13, 11, 3, 11, 15. And list 2 is containing blank. So both are two lists are there. This is a very good example. Now enumerate is nothing but the value in that particular location. So it's as good as, so enumerate of list 1, which means 4, 7, 13, 11, 3, 11, 15. That is what is the enumerate value of a particular list. Now, if you look at this, right, for index comma E, see, if anything you are not clear what it means, My suggestion is always something like this. Remove this code from this block. If you are not clear on something, remove this code from this block, put this into a new block, right? So only this part is in the block. Now you did not know what is enumerate doing. So you simply bring this in another block and you look at it. Okay, here enumerate is obviously this is not returning anything, right? Enumerate as a, but any function, what is happening, you can very well test it out in that mechanism. So enumerate is like zeroth location, first location. So in enumerate, we are having two things. One is the location, or possibly look at this. Enumerate contains two values. One is the location, the value of the location. So enumerate contains, when you are doing enumerate of a list, enumerate of anything, it contains two values. One is called as the location, the other one is called as the value. So location will be given a value of index, the value will be given E. So it means what? 0, 4 is the 0 is the index for this enumerate, 4 is the E value. Here 1 is the index, 7 is the E value. 2 is the index, 13 is the E value. 3 is the index, 11 is the E value. If you are not clear, please let me know. Any enumerate contains two things. One is the location, two is the value. To 10, we have already talked about the double equal to. If E equal to 10, so if the value is equal to 10, we are saying break. So here, few more statements. Break, continue. Break is get out of this entire for loop, right? So possibly I'll tell you, we'll take one value 10. Okay, we'll take one value as 10. Now we will, so somewhere you will get E equal to 10. So what do we mean by break? Let's look at the output. So I got only one value. So what is happening here? First of all, okay, let's not put a break right now. First, let's look at the output. So these are the outputs that are printed. What has happened? If at any point E value is equal to 10, break. Break means don't proceed later. So if this is 10, right? Don't check for all these values at all. Get out of the for loop. That means break. You will use the word break, saying don't proceed further. If E is less than 10, continue. Continue means go back to the next element in the loop. Don't do anything in this loop. So here E is less than 10. If it is less than 10, go back to the next element. That is continue. Don't do anything for this element. Just like pass, you go back to the next element. That is continue. If this is also not the case, right? If this is also not the case, then you can append. Then you can append to this empty list the index, comma, E squared. You can index, the append, and the E squared. Okay. So what does that mean? You see now, you can, if E equal to, so for 4 it will going to continue. So it will come to 7. 7 also it will going to continue. So it will come to 13. 13 is greater than 10. So it will append the index, which is 2, and E times E, which is squared, 169. Similarly, for 14, 3 comma 196. 3 will going to continue. 11 again will get printed, 5 comma 121. 15 will get 6 comma 225. Now, if there has been a 10 in the list here, right, this will get continue, this will get continue, this will get printed, and after this, there will be a break. So only 2 comma 169 will be printed. I hope you are getting it. So we have discussed so many concepts here: the break, the continue, the list, the enumerate. There are different concepts that we have covered out here. Yeah, you can use elif. Okay, here my list was not reinstated. I mean, the proper programming practice is elif only. Yeah, I think we'll go with the proper programming practice. How 169 come? We said E into E, right? 13 into 30. Yeah, these are simplified. See, normally, again, yes, possibly sometimes due to, so even this is a better practice. So first, let's stick to the practice. See, sometimes what happens is, now in the earlier case, what has happened was, it was not treated as a, you look at this. What has happened? There were two if statements, and if these two are not getting through, automatically the third line will get executed. So it's not a part of, I don't need to treat it as a part of if at all. So initially this statement was tried. So here we did not try them as a single thing. Each one was separate. If E equal to 10, break. So either it will go inside or it will not go inside. Then again, if I don't put a elif here, so it will be treated as a separate command. Yeah. This entire thing is inside this for loop. And if at all you are going to, I mean, slowly when we increase the complexity, you will find lot more comfort. Then we are going into the while loop. The major difference between a for loop and a while loop is, in a for loop, I would always know how many times I have to loop. I will always know how many times I have to loop. Is it mean that we can avoid writing anything in the last condition as we are avoiding it in case of E greater than 10? Yeah. So you can very well take it like that. Means if these two conditions are not there, then it just goes like a normal flow. Is it that way also? So it's like if this happens, otherwise don't do anything. I mean, let it go in the normal flow. Okay. So then we are putting a while statement as I am talking about it. While statement is again like a for loop. While loop is also like a for loop. The only thing is we do not know how many times the loop has to execute. In case of for loop, I know how many times I have to execute. Here, if you see my list one in the enumerate of list one. So I know there are 7 times that this loop will be performed, right? So I know how many times I have to loop. Whereas in some cases, I don't know how many times I have to loop. So possibly it's like, okay, until I get a value that is less than 100, keep looping. I don't know. Sometimes I may calculate how many times it goes less than 100, and based on that I can loop it. But sometimes if I'm not clear and I don't want to count how many times I have to execute, then I can put a while loop. So you see here, initially x is starting with a 0. Then while x is less than 10. So as long as x is less than 10, you simply say print x and equal to this means print it in the same line. What do I print in the same line? This part. X is still less than 10, adding 1 to x. And we have already discussed about this notation, self-addition. X plus equal to 1 is nothing but x equal to x plus 1. So you see here, we are continuously increasing the value, and suddenly when it comes to a 9, it is, if it is adding one more, now it is 10 is not less than 10. Now you can very well say I can write a while loop, for loop for it. So I can very well say that for is for I in 10, range of 10, you keep printing one by one, the same thing. Now you can very well do that, but there are so many problems you will come across where you cannot count how many times the loop has to run until a particular state arrives. Let's say you have taken a random number. A very simple example I'll tell you, because right now we have not discussed any random numbers, but possibly let's say I'm taking some random numbers from 1 to 10, right? I want to say while x is less than 5, right? You keep continuing, repeat this experiment, do something. So I don't even know when the random value will come more than 5. So I cannot count the number of times the loop will be repeated for me. So in those kind of cases, I may have to rely on the while loop and not on the for loop. So you have to know both of them. Sometimes people argue, if I know the for loop, is it not sufficient? Why do I need to know the while loop, etc.? But definitely both of them have their own advantage. At post increment, if we write x minus equal to 1, which is x minus x equal to x minus 1. X equal to x minus 1. Then it will be executed infinitely. X equal to x minus 1. Yeah. X has to be initialized, otherwise it will give you an error. X equal to x minus 1. So it would keep on decreasing the value. So you see this is an infinite. Possibly let us break it. So there is no way you can stop it because it is. So only I have to interrupt the execution. I hope you are getting it. Which difference? For and while, right? So for is always, you will know in for loop, you will know the number of iterations. Whereas in a while loop, you will iterate till some condition is met. This is the scenario. So depending on your problem, you will have the appropriate scenario, and accordingly you will use the appropriate loop. Okay. Then, yeah, this is the third important thing, the comprehension. So especially here we are providing a simpler for loop. So the loop is slightly, the for loop we are trying to write in one single line for a list or a tuple or anything. This is what we call as a comprehension. You look at it. This is how you write the comprehension. You first write an expression, whatever you want. Okay. For element in iterable if condition. So you follow this. So let's say I'm putting the names as one list and I'm defining hello as an expression. So hello plus name. Hello plus name. Hello is, so this is the expression that I am writing. So hello plus some variable for name in names. Names are these. So it will print hello Ravi, hello Pooja, hello Vijay, hello Kiran. So the hello plus whatever is the variable. And this variable is looping in all the names. Similarly, you see another example. Numbers, this is the list of numbers. Now I am saying, I want to print the number, right? For, so the expression is just the number. For num in numbers. So because numbers is the list, I'm taking num as a variable. Num in numbers. So it will take each and every number. If num percentage 2 equal to 0, if it is even. So this is actually printing. We are not saying print, and also it is simply taking num. So this is the expression. That is the calculation for every value. So finally it is storing only even numbers here. Similarly here you see, it will store a tuple. It will store a pair of values. Num, comma, num into num, which is like a square of the num. It will store two values, num, comma, num squared for num in numbers. So it will take each and every value if num percentage 2 equal to 1. So if it is going to be an odd only. So only odd numbers are going to come. So 55 comma 55 squared, which is 3025. Then 32 will not come because it's not odd. 87 comma 87 squared, 99 comma 99 squared, and these three will not come. Whereas in the earlier print, only the even numbers will be printed. So just go through this piece of code, or possibly you can go through them later on as well. Comprehension is easily understood by doing this. Right? Possibly I'll create a small question now for a comprehension. My question is, print the cubes of numbers divisible by 3. And I am giving you some numbers. So x equal to, we'll create some list of numbers. Okay. So I don't know what these numbers are. I want to print the cubes of the numbers which are divisible by 3. So just initially you follow this. We will follow this. So we give some name, sequence, right? Div3 is the name of the sequence. So those variables which are divisible by 3. The expression, what is that I want to print? As we have already said, print the cubes, right? So we'll say we'll take some variable, num multiplied by num or possibly we'll say num double star 3. This is like a cube. I'll print the cube. For what is the element? Num is my variable. Num in iterable. So which of them should be iterated? X should be iterated. If what is the condition we said? X percentage 3 divisible by 3 equal to 0. So this is what is going to give you div. But let's say I don't want just the num cube. I also want num as well as the num cube. Num comma num cube. I also want num comma num cube. Okay. So I will get both the values to be printed. So then I'll say this entire thing is stored like this. So rather than, I can simply say print div3. Why did this? Oh, I think the number size is much bigger. Let me do a square. Possibly it's not holding the integer. Okay. I'll otherwise put a simpler one. I'll put a num divided by 3. Sorry. If num percentage 3 is equal to 0. Okay. So you see here, only these two numbers are divisible by 3. So I don't even know which of them are divisible by 3. So these two numbers are divisible by 3. And this is the cube of those numbers. Thanks for correcting. So that's where sometimes if we write on the spot, possibly a little bit of. So generally I prefer writing them beforehand so that this kind of the variable notations and all don't get. Okay, num is a new defined variable in X. Yeah, correct. So any variable, I, num, these are some of the very common such kind of values that we would be using. Then I think one more, I think this is the last one, or slightly closer to the last in this uh, notebook. We are talking about, yeah, you can put any name. You are right. Right? That has no significance. The only thing is you have to be consistent across. So you have to try, because this is the core part of Python, right? Almost the base Python, we are almost coming to a close. So if you are compatible with these, then possibly we can very well extend. So I think from the next class onwards, we are going to look at the other libraries, the extended libraries, the NumPy, the Pandas. Now that is where we are getting into the real crux of the work. Because base Python helps us to some extent for some building blocks, but a lot of work will revolve around the most advanced aspects, which are the various libraries and functions of the various libraries. Okay, then the next thing is exception handling. Obviously, now I don't want to talk much about exception handling, but whenever when we are going to do some big things later on, we will try to spend a lot of time on this element. Exception handling is, so what if there is an error that comes, right? So any function that you are executing, any calculation that you are doing, if an error comes, now we have seen earlier for some time, if an error comes, suddenly we get some error message and the whole program stucks, right? The whole program gets stuck if there is an error message that comes. Now, this is where, and we don't even understand sometimes what is that error message, right? So generally what people do when they are writing their own programs, what they do is, wherever there is the possibility of some error, wherever there is a possibility of some error, they will try to capture that error and they will try to create a customized error message, right? So this is what is called exception handling. If at all there is some kind of error that can come, how do you handle that error? What message you want to represent? What kind of errors are possible? Right? Possibly you may say, you are saying A equal to 3, B equal to ABC. I'm just saying. Right? And finally, you want to do A plus B. Obviously, you know it's an error because these two cannot be added. Suddenly, it will give a syntax error, something. Right? Because at the end of the day, these two cannot be added. Otherwise, what I can say in the now when I am doing exception handling, I will use a kind of a try block. That is what I'm saying, try and accept. So try and accept. In the try, you write all your operations. So possibly A plus B, you will try. So you will write all your operations. The code which can cause an exception to occur is put in the try block. So A plus B is a value. And handling the exception is implemented in the except block of the code. So there will always be a kind of error value that is coming out. And if that error value is coming out, that would be mentioned. Now you see here, try. x equal to 1 divided by 0. Obviously, you know, it is going to give a kind of an error. So, so different errors are captured differently. So there are already predefined list of errors. So just try without all this. Without all this, you simply say 1 divided by 0. What is it coming out? You will see here, there is a kind of an error that is coming out called zero division error. So this is the output that is coming out in your error block. Now what we are saying, we will catch that. We will catch that error, right? If at all it is coming out as zero division error, because in some cases, if I say 1 divided by 5, that error is not coming out. So it will not go into the exception block at all, right? Whereas when when there is an error, it will directly go into the exception block, right? Let us run this. So here, only if there is an error. So here when I do a 1 divided by 0, it would have come out as an error. And because it was an error, suddenly it will go into except, right? So it will go into an except and it will simply say, right, print this message. Print divided by 0. Print executed when exception occurs. Executed when exception occurs. So it does not go into this else block now. Else block will come only when there is no exception. But this part will still be there because the block is only up to here. Finally, print finally block always executed. Print finally block. Otherwise, let me just make it here. 1 divided by 5. Now, this is not an exception. So it does not go into this except block. It will only go into this else block. Executed only when exception does not occur. Finally, block always executed. Finally, block always executed. So this is continuation sequence. So what we simply say is, if I really don't want that odd thing to come out, I can very well come out with this kind of a mechanism also. When we simply did 1 divided by 0, I got a kind of an error which is not that user friendly to understand, and the system execution also stopped. But here it does not stop. It keeps continuing. Okay. So that is one more important thing. Possibly let me see if there are queries. So we have already seen, right? Zero division error. Anything divided by 0 is a zero division error. So that's a Python giving error. So you simply do 10 divided by 0 something. You get this error message as zero division error. Right? So it is already existing as a part of the Python error list. So what we are saying is Python, if I don't do any exception handling, then Python will throw the error like this and it will give me a kind of this error message. Now, if I really want to create my own error message, customized error message, or do something, even if the error comes, keep continuing. If I want to say, sometimes I may want to do that also. That would not be ethical, but just want to go ahead. Then I say, if it is zero division error, continue. Then I will not get the error, but I will still continue going with the problem. I think our friend Ashok has shared something. Just look at it. Right? Possibly, yeah, you should look out for all the links and all the documents that are shared so that it's a collective learning. Now, I'm talking about modules and packages and the import function. Now, as I told you earlier, there are so many extensions that are written on the top of Python. So many, thousands and thousands, possibly. You visit this PyP. This is the index of all the Python packages, right? You see, there are almost 4,26,000 projects, right? And so you can find so many libraries that are there, right? Possibly you can name one or two areas. Let's say time series analysis. I put a time series here. You see, there are so many packages that are created by people like you and me to work with the time series data. Now, how many of them are really good? How many of them are worth using, etc.? The better way for us to look at is you click on this and you see generally you will have something like stars and how many people are using. Okay, possibly this is not the one. You look at the trending. And possibly let's type for insurance. What are the packages that are there for insurance? So there is some package called Insure Auto ML. Only 4 stars are there for this. Stars are like, I mean, sometimes some packages have some hundreds and thousands of stars. Now, those kind of packages are worth experimenting, right? How do you experiment with the package and all? We will discuss about that. But quickly, for your domain, for your area of understanding, what kind of packages are there? Generally, the best ones are the ones, especially with a good number of stars, right? Possibly we'll go with the relevance only. Automate insurance pricing. This is having only 2 stars. 4 stars. Some more additional copies have been made because some more people are planning to work on it. So it's like because this is all open source, how many people are working with parallel projects on the top of that. So stars are a very good way for you to really see, can I rely on this package or not, right? So possibly I'll say Y Finance, which is Yahoo Finance, getting the data from Yahoo Finance. I see here stars are 8,400 because so which means more number of people are using because they are downloading. If they want to download the stock price data of different stocks across the world from Yahoo Finance, they are using this package. So this package will become a very reliable package, right? Possibly the other packages, they are also, so here there are only 2 stars. So people are writing different packages, but definitely not all are of the top class. So here we are talking about modules, packages. So module is a collection of functions and variables that have been bundled together in a single file. You can write one single module, right? You can write one single module where you put a few variables and you put a few functions. We did not define the function yet. So you put a few variables, you put a few functions, and you save it as a Python file, separate Python file. And you can use that Python file in the new file that you are creating. Because this is nothing but a list of, now, one of our friend was asking earlier, some of the values they are getting erased off. Now you fix the values of the variables and save it as a module, which is like a Python file. So all the values are fixed there. you import that Python file into another Python file, right? Let's say I'm doing chapter 1. I saved a few variables, I wrote a few functions and saved it as chapter 1. Now in chapter 2, I can import this module called chapter 1, which means I don't need to rewrite that function again. So if I am writing that, if I am basically the meaning is, if I am using a particular, I wrote a particular function and I want to use that function in multiple files, in multiple notebooks, then I can create a module of that particular function and I can import that function in all the notebooks rather than writing that function every time in every notebook. That is called as a module. So module is nothing but it's a Python file. So it generally has py extension. So any Python file that has a .py extension, I can use it as a module. I can import it in some other Python files and I can use its functionality as well, right? And package is something that is independently existing. So it has its own initiation file as well. So that is what will become a Python package. So package is self-existing. Module also is self-existing, but package is something which you can even upload it to that PyPy location, and people can very well import that package and they can directly use all the functions of the package. And namespace is based on the file's directory, where exactly that location is there. Now, so here module, package, all are there. So basically a math is actually a package. So import math. The moment you are able to import this math, then you can use, or now let me do this. Import math. Now math dot. So I can do all these things. I can get the trigonometric values, ceiling, combination. So you can see there are so many factorial. So I'll say math dot factorial of 10. I'm getting, this is the 10 factorial value. So what is happening? These all functions are not there as a part of the base Python, right? So some people, they have taken the base Python, they have written all the mathematics functions or possibly whatever they could using Python, and they have attached it to the Python library. So which means some additional modules are coming, additional functionalities can come in, right? So I can say if I want to find out the 10 factorial, possibly I can write it using the base Python also. Now, how do I write the same using base Python? Let us try, right? X equal to range 1 to 11, right? This is what I'm saying. Then for num in range, sorry, for num in x, for num in x, so we'll say fact is equal to 1, right? And then here we'll say fact equal to fact into num. and then we'll go with print fact. This is when we are using the core Python to work. Oh, every languages. Okay. So here also I am getting the same answer. Or possibly you can use different. So possibly you could very well instead of using we can very well go with a combination. You can very well go with your comprehension of the list, and you can very well you can very well try out doing this. So whereas if I use this import math function, I can very well directly use factorial, right? Factorial is something that is already created as a function there. So I can directly use it. Whereas here there might be a function, but I may have to go from the basics. Whereas here, people have already created some such kind of a function. So I can reuse that function. Okay, since we are working on Colab, which is not installed, so I'll tell you. So there are so many packages that are pre-installed along with Colab, right? Colab is also it has a Python environment with it. So there are so many packages. So the environment of Colab, just like Anaconda environment, comes with a lot of pre-built packages. Here also the Colab environment comes with a set of pre-built packages. But if at all something is required, we will. I'll show you how do we install that. Right? We have not yet. So this math is already installed. Math is already pre-installed. So as Saurabh is mentioning, Colab comes with certain pre-installed packages. If additional, so pip install. Yeah, you are right. So pip install, the package name is going to install the new packages even in Colab also. You are right, Saurabh. Any of in the next module, I am going to cover that in the next class. How do we know beforehand which packages are in Colab and which are not? So if you are actually doing an import, and if that import is not working, you can very well try to install that particular package. Isn't it the 10, the location 10 from the math package? The location 10. What is that location 10? So the 10 is factorial of 10. If we want to print the factorial from 1 to 11, so just move this print function inside this indentation. Just try to move this inside this indent. That is where the indentation matters a lot. This is what I think you are expecting. Okay. So then the last, I think I'll cover this and then we'll finish it off. So then the input output. So especially if you want to access or store this to a particular location in a Google Drive. So here there are two things. One, whatever you are writing, you write it it to a Google Drive, or two, you write it to a physical location in your directory, in your computer. There are two ways. So right now I am covering the Google Drive part. So what you can do is, you can very well give the location of your Google Drive, the path of the Google Drive. I mean, right now, I'll spend some more time on it. So here I have my drive, Colab notebooks, IAI data science. So that is the directory. And so I can very well print the path of that directory. And I'm creating a file called vamsifile.txt. And I am opening that file in a write mode. So you could see here, if I want to write something to a file, of course, that's a very big input-output operations are slightly a bigger aspect. But definitely, just to give a very basic intro into it. So right now, I am saving it to this directory in my Google Colab notebooks. So this is, I am having my chdir is change directory. So right now I am giving only the Google Colab, Google Drive library location. So my drive, so if I look at here, I'll see there will be a drive for me, right? So of course, we did not import anything. So right now that drive will not be accessible like this. So I'm just giving the path of this. And now I am opening a new file called vamsifile.txt. And I'm opening it in a write mode. W is write, R is read. So I'm looking at it as a write mode. And I'm writing. Now if you see, because I'm opening it, this vamsifile.txt, I'm actually taking it as F. F is another variable I'm giving. So f.write, this is my first line, f.write second line, f.write last line. So these are the 3 lines that would be written. So if I write this, okay, because I have to actually mount the drive. So right now ignore it, because I have to mount the Google Drive, possibly I'll have to write one more line of code here. Right now, don't bother much about it otherwise. So this actually will give access to the Google Drive. You will have to give access to your Google Drive so that it can write to that Google Drive. I'll discuss about it in the next class, don't worry. I'll give access, I need to give access to the Google Drive. Now I think I should be able to do this. So now it has created a file called vamsifile.txt in this folder. So possibly let me look at the folder now. So now you see drive, my drive. Then I have Colab notebooks, IAI data science. So here vamsifile.txt got created. Now I am trying to read what is the content of vamsifile.txt. So with open in a read mode, and I am writing a for loop here. For line in F. So for each line that is there in F, you are simply printing the line. So which is nothing but we are printing the whole content. So this is my first line, this is my second line, this is my third last line kind of thing. So we will focus more on it, right? But definitely this first particular notebook is completed. I want you to practice this notebook to whatever extent you can, because it's a very important learning. In the next class, still I would be discussing a little bit about the functions, and after that, we would move towards NumPy, which is a one important library. So we will get into the libraries. So I will be sharing this document, this notebook, and possibly over the weekend, I want you to practice a little bit more. Try out your own queries. Google them. For every query, if something is not clear, Google. Let me tell you one important mantra here. The R and Python, the two languages, they are so sophisticated that you simply query something you want to do, you will get the code available. So you don't need to come back to me. Once you know the basic structure, once you understand the basic concepts, you don't need to come back to me. You directly Google out, you will get the result, you copy that into your code, run it. So that is the kind of comfort you should keep getting, because code wise it is available everywhere. Now you need to know what is the problem, how do I solve that problem, and what are the basic constructs. Now if some error is coming, what is the reason this error is coming? So the basic constructs, once you know, after that it's all about Googling, right? So we will keep seeing how to take help of Google as we move further as well. So I'll stop this here, right? In case you have questions after you practice over the weekend, please use only the WhatsApp group for posting your queries, because someone else can typically answer those queries as well. That way we can accelerate our learning process and we can move further, try to cover more and more concepts. Okay. Thank you everyone for attending the session. Hope the first week has been fruitful for you. Some of you, I'm sure you guys are all comfortable with Python. So for you, it might be a little bit boring, but definitely it's a kind of a quick walkthrough of the various concepts. Okay. Thank you. Thanks a lot, everyone. Happy weekend. Take care. Bye-bye. Yeah, I'm sharing the new notebook again. After every class, I'm going to share that.